Electrical cable, it's quite simple. Blue one goes to blue one. Brown or black goes to brown or black. So if you've got any crossover where there's any electrical current passing from one wire to the other one, you've got a problem with your cable. You've got a real interruption there and noise between the various cables, and actually you're not allowing it to Hello and welcome. It's the first time I'm actually going live. What we're going to be doing today is fixing any type of cable that you may have. It may be busted and broken, and I'm going to just go through the quick and simple steps to restore and revive any cable. Cable could be anything. Today I have an XLR cable. XLR has 3 pins and is great for any audio visual items. Can be used for microphone, anything else, but the same principle can apply for network cables, electrical cables, so anything in regards to full-on electrical cables or any type of cable, and that's the first thing that you need. The next thing that you need is you need a simple multimeter. It doesn't need to be fancy. It doesn't need to be expensive. What you do need to be able to do is measure resistance. If you have a fancier one, you may be able to also mark it to continuity, which will just buzz away if there's any issues. If you didn't want to use this and you didn't have a multimeter and you're really up against it, maybe something along the lines of a small DC current with a light bulb, just to make sure that there's any interruption or connectivity. I won't go through that today, but I'm just going to be using the multimeter to keep things simple. You need something to mark wherever there may be any problems within the cable. I've decided to use electrical conduit tape. It could be any type of tape. It could be any type of marker. You could just use a pen. It doesn't really matter. It's just we're going to identify where the actual issue is so that we can resolve it. The other thing that you're going to need is you're going to need something to strip the wire. It can be a Stanley knife or a knife of sorts. It can be anything that you have. And you will probably need some type of pliers. You don't have to, but it does come in useful, or some kind of wire strippers, something along those lines, or something better. Anyway, I have them available should I need them a little later. Okay, so let's get into it. I'm just going to move this out of the way so it doesn't get in the way. The first thing that we really want to do is identify any issues. I have checked this cable beforehand, and I have got some crossover connectivity issues. So what that means is that each one of these pins, so here you'll see it just on the camera. Oh, not going to use A's focus, blah blah blah. However, you will have seen that it's marked, that one there is marked with a 1, and the 1 should correspond to the equivalent on the other side. And it doesn't matter what wire you've got. If you've got network cable, it's the same thing. You can look at your wiring diagram and you can see that how things are wired within a network cable. Then you may have crossover, you may not. However, it's whatever you want it to be in regards to the wiring diagram. Not whatever you want it to be, it's what's actually described as there. Electrical cable, it's quite simple. Blue one goes to blue one. Brown or black goes to brown or black. So if you've got any crossover where there's any electrical current passing from one wire to the other one, you've got a problem with your cable. You've got a real interruption there and noise between the various cables, and actually you're not allowing it to function. If it was just passing one type of current or one piece of information, not a problem. But when you've got multiple lines of information, it is a problem. So within this cable, I have crossover. And the way that I'm able to identify that, and it doesn't matter about the length, is first of all trying to expose through the connections. What we want to be able to do is use our multimeter and confirm through the resistance if we've got any crossover. So the first thing that we want to check is, does pin 1 go to corresponding pin 1 in here? And if it does, then we are good. The next thing you want to do is you want to check pin 1, is it actually crossing over to pin 2? If there is any type of current going through resistance there, then if it's low resistance, then we've got crossover. If it's not low resistance, then we haven't got. If it's very high resistance, we haven't got crossover. So simply putting it, we can do this one of two ways. We can use the existing side to validate this. So what I've done is I've set it to resistance. Let's get that in so you can actually see it. Oh, bit of glare. Great. So I'm just going to put this into pin 1. And if I put this into pin 2, not going to fit. As such, you can see that there is low resistance against that. What that means is that there is effectively a loop or a connection somewhere in this cable between a pin and another pin. So somewhere in this wire they're connecting, and they shouldn't be. What should actually happen is that it should only effectively go through that one wire to the other side, and there should be no connection. So there's a fault within this wire. We're going to find out where that fault is. So there's a simple way of doing this. You can use the existing side, and as I've done there, and just put the 2 pins in, or you can expose it and you can connect the 2 sides across the other points. So if I'm checking just across there, we're seeing some resistance, and we're also seeing it against this pin here as well. So we can connect it across both sides, and I find that's a little bit easier for me, but you can decide to do it either way. What I'm going to do to get to the actual cable is I've taken it apart. XLR is very, very simple to change, to expose, and all we need to do is just unscrew the cap, and we've got the various wires exposed, and we just pull this back ever so slightly, and now we can actually see the wires. And also I don't then have to worry about the pins because they're color coded for me. Makes it nice and simple. So I'm just going to open that up, pull that out, place it on the side, and hopefully not lose it. Do have a tendency to do that. Aha, we've got something here. So what I'm doing is I'm trying to actually find the point where there's a large jump. Before I was doing quite wide movements, so I was flexing quite a lot of the wire. Now what I'm doing is I'm just focusing on little sections and seeing. So we have something here. So what I'm going to do is I'm going to mark it before I lose the position. Now this is not going to be the most accurate mark, however it's really going to help us identify generally where the problem is. Now there is one downside, is that you can do this if you want to be really accurate. You can actually go ahead and pinpoint specifically where the problem is, or you can actually splice and cut both sides of the wire and actually reconnect them. You can do that through a solder joint or something along those lines, and then just reconnect it. Now I do ideally like to just splice a little section off, and we'll probably. I'm just going to take the knife around the edge of the wire, making sure I'm not actually cutting through, just getting through the outside layer. I'm going to give it a little flex to get through. Yeah, I'm through. Perfect. Now what I've done is I've got through. I'm going to do the same thing here. And what I'm doing is I'm just exposing the wire. It's not the cleanest mark. So I can take just the outside layer off. Okay, I've got through. Perfect. Without actually cutting directly through the cable, just the outside layer. And what I'm going to do now is I'm going to run along the top, across, not across the wire, but just in the same direction of the wire, but just slightly edging, just to take the outside insulating layer off. Perfect. Now what I want to do is I want to see, is there anywhere that we can actually see any specific problems? Are we actually getting any problems with one layer connecting to the other layer? Now I've got to hang up soon, is I'm just going to show you how you would go about repairing it. So now that I've kind of shown how you would work out where the error actually lies, and how we would actually expose the wire to find the connection, which is great. So we found that out. What we're going to do now is just how would we go about repairing it. So there's a couple of ways with this outside layer, and it being pin 1, is I've got to be very careful about how much I take off. So I can actually cut through just the outside layer and expose the underlying wire, which is just there. I'm going to slowly piece it out. And what I could decide to do is clip there and there, or I could take the easiest option, which is let's cut out the offending section, which is here for us. Re-expose the various layers. That we have. Perfect. And because this is very similar to a cable or satellite wire that you may have, is we've got to try and reconnect this in such a way. So we want to get rid of the fluffy areas and any of the kind of it's not really insulate. I think it's just a bit of protection more than anything. So how do you identify that actually we've caught all of the connections between the wires, and that everything's working fine? Well, it's quite a simple test. we just take our one side of our multimeter and against the other side of the connector, making sure it's the same pin, and just check the resistance. Well, we're good for that side. We check the other pins. You can see that there is complete resistance there, and again against the last pin. So this side, which is the smaller side of the wire, is absolutely fine. However, we need to do the same thing on the other side. So take the red pin and make sure that it is fine against the red pin. Yeah, however, there is also resistance against one of the other pins. That means we haven't caught all of them. So you just repeat the process, and I did exactly that. I've marked up my next knot. You could actually see a little bump in there, so that's actually going to be a better one. And you just repeat the process. I mean, it's not great if you've got lots of knots. It's not probably a great wire, but you'll end up saving your actual lead. So just repeat the process and you should be fine. Okay, so now that I've actually cut the part out which was causing us the issue, and there must have been a fault in this section, I've now stripped back the wires, and I've just used my wire strippers. You can use a Stanley knife, you can use pliers, whatever you like. The final bit is actually joining the two together. Now there's a couple of things that we can do, and one is we can actually go ahead, join, twist and solder. The other method is actually using something like a connector, which I was using before, just here, to connect the two terminals. Sorry, it's a terminal, but just to connect the two terminals using connecting the two leads of the wire using the terminal. Or you can use electrical tape. It's not going to last. So the method that you use is the method that's going to last the longest. I'm not going to be going through the soldering method, or I'm not going to be going through the taping method, or using a connector. It's fairly simple. You just screw everything in, or you tape it up together. I will, however, in my next video be showing you how to actually solder the two wires together. There's a bit of extra equipment that you need, but I am going to solder the two together. Thank you so much for watching. In the comment section, please like, subscribe, leave a comment. What did you like about this video? What did you not like about this video? If there's any other wires that you would like me to reconnect or to walk through this method with you, please place your comments below.